So this is what I do a lot of, trying to design optimal restoration using funds as efficiently as possible, and just trying to see how you can get the results you want. So these are the countries that have to cooperate to try to clean up the Baltic Sea. Some are EU members, which essentially gives them an overarching structure of government to make decisions, but then the blue countries are outside that structure and they have to bring them along too. So their restoration goals for the Baltic, they're trying to restore the aquatic habitat, and they're primarily going about it by thinking about water quality parameters. So they have set this goal of good ecosystem status, and later on, I'm going to tell you how they used a valuation survey, and what they asked about in this particular valuation survey was things like how much people valued water clarity and blue-green algae blooms, both harmful and regular, seagrass, fish, and oxygen levels. So really, we're very much in this intermediate good situation where water quality potentially delivers a lot of good things, but they actually haven't tried to measure exactly those good things, the fish a little bit. This is your basic optimization idea, is that you establish what you're trying to optimize. And in this case, they were looking at maximizing the net present value. They're looking at using a biophysical model. So there's a watershed model, there's a model of the marine system itself. It can be very complicated and have many pieces, but this is what tells you if I impose these management actions, such as best management practices or wastewater treatment plant upgrades, I will get this kind of biophysical result, like oxygen levels or something like that. And then the survey on values tells you how much people value that outcome. And that allows you to do a cost benefit analysis to say, and you iterate through this many times to see how do you maximize the benefits, once you've subtracted off the cost of doing what you would do. And then the net present value is, I'm looking at a stream of services in time, and I'm summing them all back up in current dollars using a discount rate. What they did was pretty interesting in that they looked at a variety of policy goals. So the first one, there are these load reduction targets for the Baltic as a whole and for sub areas, and they just said we're going to meet all those. So that doesn't really need a cost benefit analysis. You're just saying meet all the goals, what's the cheapest way to do it? Then the other question was, what if we looked at meeting sub-basin goals cost effectively only? What would that look like as opposed to the overarching goals? The other one is only meet the larger water body goal. The next one is really using economics to optimize the nutrient abatement so that we're creating the most benefit to people. And then finally, this one kind of brings in some of the political realities. We want to optimize the nutrient abatement, get the highest net present value, but we want to guarantee that no country has to spend more than they get back in benefits. So that's a real kind of constraint you might have in real life. And you can build this all into the system. It doesn't just have to be maximize net present value. You can say, well, we also want to make sure water quality doesn't ever dip below this in an area. We also want to bring in political constraints, like every country has to be a winner. And so these things can be quite complex and not as, single-minded as you might think. But now we get into this bigger question of what does fairness cost? This map on the left shows how they allocated nutrient reductions to each country based on how much they polluted. So this is kind of, if you did it fairly, so this, they called it the polluter pays principle. Everyone who was polluting into the Baltic had to reduce a certain proportion of how much they were polluting. And the costs of that were 2.8 billion euros, the benefits for 4.6 billion euros, and the net benefits was 1.8 billion euros. So that's a pretty good outcome. The policy delivers net benefits. Why not do it? Well, the economists, being economists, couldn't resist and said, well, but is that the most efficient way to do it? And so they optimized, and they said, you could not fundamentally changing the nutrient targets. What if we allocated effort according to who had the cheapest options available. And so this essentially would be like a trading idea. Instead of everybody doing their percentage of their pollution, maybe people who polluted a lot, but who have already done a lot, like Germany is a great example. They've already upgraded all their wastewater treatment plants. They've already spent a lot of money on farm implementation that would reduce nutrient runoff. But Estonia, Latvia, and Lithuania haven't done hardly anything. And so Germany could simply pay Estonia to do some simple things that are cheap there because they haven't done the cheap things yet. And then the total costs go down. And that's what the right side is showing, is if we just allocated effort according to the most cost-effective practices, the cost dropped dramatically. So now we're down to 600 million euros. The benefits are very close, 4.3 billion euros, and the net benefits are now 3.7 billion euros. So this is essentially the cost of fairness, the difference between a net benefit of 1.8 billion and 3.7 billion. And so, but of course, that the allocations had already been set and it was a very politically difficult negotiation. So they didn't just take this analysis and go, okay, we'll change everything. But they did use this to try to think through policies that would help them achieve some of these cost efficiencies. Why don't economists measure more values? I get this all the time. What about cultural values? What about sense of place? Why don't you measure that? And the answer in the main is we need the causal links that would let us understand how those changes happen. So we know we can do an action like restore a wetland. And what an economist wants from the ecologist is, if I restore that wetland, what's an outcome that people really care about? Like probability of a reduction in toxic algal blooms. That's already really hard to do, but maybe we could do that, right? And then we still need to go to, okay, but how does that actually harm people? Well, a common way it harms people is exposure in contaminated seafood and health. So we're relating that ecological change to something that's very specific about human well-being. And we'd like to do this because we don't necessarily want to ask people directly about toxic algal blooms, because they may not really have a deep understanding of what that means to them. But if you say to them, what's your willingness to pay to avoid getting sick from bad seafood? Well, that's something that they have more familiarity with, and they're going to be able to value that more accurately. So that's why we would like to translate these things into something that people have familiarity with. And then finally, we can use various methods, revealed or stated preference, to get at that value. And just to be clear, the study I just showed you kind of jumped over this third box. You can do that kind of valuation. People do just generally have values for things like water quality and ecosystem health. But some of us believe that it's better to try to relate that to more specific outcomes so that people can really understand the trade-offs better. What do we do with these values? So we're doing two things with this optimization modeling. We're looking at, as you implement different kinds of practices, you get different bundles of benefits. You can think of these as ecosystem services if you want, but we just tend to call them different kinds of benefits. And some sets of practices might be efficient. They might give you a certain mix of benefits, but really what we care most about is whether we're growing the total bundle of benefits. So on the left-hand side, the pie is smaller to represent the fact that when you do the allocation of effort differently, you actually get a bigger pie of benefits. You spend a lot less and you get almost the same benefits. So looking at these bundles helps us weigh the trade-offs and maximize well-being. Now, some people may feel like they don't care about people's financial well-being as much as they care about climate change, right? But when we do this, everybody gets a vote, and everyone who's benefiting, every stakeholder kind of gets their say. And so there's no, we don't impose anything. It's not only financial well-being, but if that's the main effect, that's what we're going to measure. So that is one of the ways that we use this. Another way we use this, and we would like to be asked this question more frequently than we are, is how do we set the pollution targets to begin with so that we're balancing benefits and costs? So in this study, using that optimization model, they showed that as you moved across efforts, so 0 is starting out with not reducing nutrients at all compared to present value, and 1 is meeting this BSAP target. And you see what we frequently see is that the benefits, the net benefits, these are, start to diminish the closer you get to the target. So they set a very ambitious target. Currently, maybe we don't have all the technologies to get there. It's very expensive to do that last bit of mitigation. And so an economist would want to look at what does the cost curve look like? And I showed you some cumulative cost curves yesterday. This could be cumulative or marginal. And we would use that cost curve to try to understand where the benefits and the costs balance. And they might, using that, we might have set a higher cap on nutrients, which is what those blue lines are representing for different, but again, that blue line will move according to exactly what your goals are. So just to sum up here, optimization modeling allows valuation to be used to examine approaches that would maximize net social benefits. That maximization can include political and technical constraints. And the cost savings of optimized policies versus what initially gets proposed can be substantial. And in the Baltic example, achieving a healthy Baltic, the total cost of it could be halved if the mix of measures and the regional targets had been planned in a spatially cost-effective manner. But that said, there's often a very big barrier to achieving the optimal. And so it really requires a lot of legal and political flexibility, and even what some people refer to as policy entrepreneurs, because sometimes you're really bucking the system to try to do something different, but the potential cost savings can be enormous.